Hi, everyone. I want to take a few minutes to go over how we can do both the chi-square goodness of fit and chi-square independence tests on the calculator. So starting off with goodness of fit, if I look at this one, we have, we want to see if there's a time preference for the class to meet. So we have 4 different options here and how many prefer, and we want to see, do we have enough evidence to show that there's a preference for a time, right? So remember, I assume the opposite until I have enough evidence to prove otherwise. So my null hypothesis is that there is no preference in time. And my alternative is that there is a preference in time, right? So if I want to show there is no preference, that means all 4 slots are equally preferred by students, right? So if I add up all my values, it looks like we have 116 totals. So if I divide that between the 4 categories, no preference for me would mean that there's 29 in each class. So my expected is going to be 29 for each class. Okay, so for work for this test, if I'm doing on the calculator, so what I want, or what I would expect, so to find our critical value, so alpha was 0.01. We said we have 4 categories, so 4 minus 1 would give me 3. Okay, so degrees of freedom 3 with 0.01. So if I go to my table, 3 is this column, 0.01 is all the way over here. So 11.345. Okay, so if I find my critical value, so the way we do this on our calculator, so to calculate the test value, first step you want to do is type it into L1. So go to stat, edit, so type it into L1, L2. So observed would be L1. So my 4 categories expected is the 29, the no preference. Okay, so I go to stat, go over to tests, and if you scroll to the bottom of the list, you should see chi-square GOF, so goodness of fit test. So D in this case. So if you click that, it'll verify observed is L1, expected is L2. We said degrees of freedom is going to be 3, so we have to input that ourselves. And if I calculate my test value, it looks like we get about 2.55. Okay, so rather than doing 24 minus 29 squared over 29, 35 minus 29 squared over 29, observed minus expected squared over the expected, the calculator will do all 4 of those for us. And as you can see, it gives you in this last row here, it gives you, if you go in that last row, it gives you what each of those fractions would give you. So it gives you all 4 of those. So I can make my decision based on this. So it looks like 2.55 is not going to be in the critical region, right? So it looks like we don't have enough evidence to reject this. So we don't have it. We can't show that there's a preference in time. So we can say the differences are just due to chance. There is no preference in time. Remember, you can also use your p-value. So my p-value here is 0.466, which is much larger than alpha, right? So remember, if I have a larger area, so basically this area plus more area, that means we have to be outside the critical region. So if p is greater than alpha, don't reject h sub 0. Okay, so if I look at an independence test, so we'll look at this example. We've done this already, but we can use our data. So you have to do a slightly different, it's a little more complicated than the goodness of fit test. Okay, so we want to see if there's a difference in favorite sport for males and females. Sports preference and gender are my 2 variables. Okay, so can we conclude that it's related, right? So my null hypothesis is that they're independent, they're not related. My alternative, what we're trying to prove is that sports preference is related or dependent upon gender, so they are dependent. So the way we want to deal with this is you want to put this into your calculator, but since we have 2 rows, 3 columns, I can't just do L1, L2, we have to use a matrix. So if I go to matrices right above this key, so we click on second, x -1, you see mine are all blank. So if I go to edit, I go put it into A, and remember it's rows times columns. So we have 2 rows. So those are the horizontal, and columns is vertical. So we have football, baseball, hockey, 3 of those. Okay, so this will give you 2 rows and 3 columns. So I could type in the 18, click enter, 10, enter, 4, enter, 20, 16, and 12. So I could type in my values. Don't type in the totals, right? So just the values. And you could quit out of this. It'll save. So if you go back to the matrix menu, you can see now it has a 2 by 3 save. So it tells you what's saved. Okay, so to get your test value, well, first, before we do that, we should calculate our critical value. Okay, so to get degrees of freedom, remember we do rows -1, columns -1. So we have 2 rows, so 2 minus 1 is 1. And we have 3 columns, 3 minus 1 is 2. So 2 times 1 is going to give me 2. But you can tell the calculator will give me that as well. So degrees of freedom is 2. Our alpha was 0.10. So if I go to here, so degrees of freedom 2.10, if I go across the row here, that will give me 4.605. So 4.605. Okay, and as you'll be able to see in a moment, you could get the degrees of freedom from the calculator as well. So let's go over to our back to our calculator. So if we go back to stat, go over to tests, right above the goodness of fit test, you'll see just the regular chi-square test. See? Okay, so our observed values, these are our observed values are in A. So all you have to do is click calculate. It'll tell you the degrees of freedom 2, right? So if you forget how to do this, you can get that from here as well. Okay, it looks like my chi-squared is going to be 2.385. Okay, so for work, if I go back to my matrix menu, so second matrix, you could see it said when I clicked enter that expected was in B, right? So it created a matrix for us in B, a 2x3 matrix, and it put our expected values in there. And you could see those here, right? So, or you could go to the edit menu. You could see it there as well. If you edit B, it'll give you those values here, right? So it looks like expected would be 15.2. So I do want you to write the expected for each of the categories. Okay, so remember to find the expected, you have to do, for each element, you do the row sum times the column sum and then divide by the grand total. So you would do that for each sum. So rather than doing that, you could have the calculator do it for you. And for work, so I do observed minus expected. So if I do the male baseball, observed minus expected squared over expected. So you don't have to write out all the fractions. You could just put like the dot, 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 and then the last one will be the 12 minus 9.6 squared over 9.6. And that will give you the 2.385. Okay, so you should show how the calculator gets it. You don't have to write the whole thing or type the whole thing in the calculator, but you can write a shorthand version of that. So 2.35 is about half of 4.6. So 2.3 is going to be outside the critical region. So it looks like we don't have enough evidence to reject. So we don't have enough evidence to show that they're dependent or related. So we have to, our conclusion is that right, they must be, they're independent. We don't have enough evidence to show that they're related. Okay, so that's how you can get, so it'll create the matrix, and you don't have to clear anything. If you do it again, it'll always put the expected into matrix B. So you could view the expected values from here and get chi-square from that menu as well. All right, and just to show, if I go back to that chi-square test, you could see it gives you p-value, which is 0.30 here. And once again, 0.30, our alpha was 0.10 here, I believe. So yeah, 0.30 is, sorry, 30 hundredths is more than 0.10. So once again, if it's a larger area, we're outside of the critical region. So you can use your p-value to make your decision as well. All right, so that's how you do both of those tests on the calculator.